Hi, welcome to Joy for STEM Live. I have a few people I'm trying to get connected to, and so if you guys give me 1 second, we're going to start our event. Today we're talking about acids and bases and pH indicators. So let us, yes, I got my little scientist here. Rick, you want to come say hi? Here, let's see. Hi. Yes. Awesome. Yes. All right. So I'm going to let you sit right here. You're going to join us. All right. So today we're talking about, sorry, go ahead. Go on, little scientist. All right. Awesome. Joy for STEM Live. All right, so today we're talking about acids and bases. So what exactly is an acid and a base? Well, first you have to understand about solutions. So what's a solution? Well, have you ever had Kool-Aid? Have you ever had a nice juice or maybe even milk? All of those are solutions. Solutions are a mixture of different molecules put together. And in this case, we're talking about aqueous solutions. Aqueous. Aqueous sounds a lot like aqua. So could aqueous mean water? Yes, it does. Aqueous solutions are solutions where water is the main part, or we say is the solvent. So today we're talking about solutions that have hydrogens. So in the back, I don't know if you can see, I have a periodic table. Hydrogen is the first element in a periodic table. And acids are solutions that have a lot of hydrogens that they can donate. Whereas bases like to accept these hydrogens. All right, so if you've come to join us, if you could just wave or say hi so I know that you're here. I would love this to be interactive. And if there's any little ones, I just say welcome. And also if you could just comment on the age that they are so that I will know exactly which age to direct my information to. All right, so in the meantime, let's talk about how to produce these pH indicators. So now pH indicators are things that change colors based on how acidic or basic something is. And today we're talking about the pH indicator in cabbage. So what is that called? Well, cabbage has, hi. All right, so cabbage has what we call flavin in it. And a flavin, you can see it there, F-L-A-V-I-N, flavin, and that's what actually changes colors in the cabbage juice. Now, I made my cabbage juice early, which is right here, but all I did was take a red cabbage. All right, this is a red cabbage. It looks purple, doesn't it? I always wondered why they called red cabbage if it's purple. But hey, I didn't make it up. Kind of looks like a brain once you cut it open. But anyway, so I took this red cabbage and I boiled it for about 10 minutes and let it cool. Now, once I did that, I went and filtered it out and I have my red cabbage juice. Now, this is going to be my pH indicator. And what's going to happen is going to change colors based on the acidic levels. Now, because water is a solvent in my red cabbage juice, it is actually going to not be red or purple, but blue. And I have this to show you guys. So I have my cup here. If you notice, it actually is blue. See it in there. And this is because water is what we call neutral. So we talked about acids and we talked about bases. Well, water is what we call neutral. That means it's neither an acid or a base because the hydrogens and the hydroxide ions are balanced. Okay, so we have our water here and it's nice and blue. Now, the question becomes, what happens to my solution if yes, blue, if I introduce an acid or base? So I'm gonna get my little helper. Come on, Rick. Yeah, that's an M. Very good. He's been learning his letters. All right, Rick, look. All right. So some of the things that Rick likes, believe it or not, he likes lemons. You like a lemon? Yes, a lemon. And lemons are yellow, right? Lemons are yellow. So lemons, have you ever tasted a lemon? It's nice and bitter and tart. Let's open it up. Ooh, have you ever had a nice cold glass of lemonade? Yes, fresh squeezed lemons. You want to taste it? You know we're in the lab. We're not supposed to eat in the lab, Rick. That's what we always do, our food things first, because he likes to taste it. Nice and bitter? That's right. All right, so we're going to mix up our cabbage juice with our lemon juice. And so that you guys can see it. Oh, there we go. Let's squeeze it in our plate. Now the question becomes, is the solution, the lemon juice in the lemons, is it an acid or a base? Well, let's find out. All right. Let's put a few spoonfuls of cabbage juice in there. Now, parents, this is a great way to teach your kids about colors. They may not understand the words acid or base, but you still expose them to those words. And in the meantime, they can learn all about their colors. All right, so let's get some cabbage juice. Now, one thing we also want to make sure when we have our cabbage juice that we don't cross mix the colors together. Because if we mix them together, then it will what we call contaminate the cabbage juice, and we need a new batch after that. As a matter of fact, I usually make a couple of batches just in case. Wow, look at this. All right, let's see what color it turned to be. Let's see. That's nice and pink. You guys able to see? Let's put it in a cup. You can see it better in a cup. Wow, what color is that? You like that? That's pink. Can you say pink? Wow. You say wow. Yes. Yay, it's pink. All right, boys and girls, the reason why it's pink is because we have a chart called a pH chart. And the pH goes from 1 to 14. Now, oh, come on, he doesn't want to miss out on the fun. Now, for colors, or well, let me say this. For acids, that's when the pH is lower than 7. So that's 7, well, that's 6, 5, 4, 3, 2, and 1. Those are what we call acids. And anything above 7, so that's 8, 9, 10, 11, 12, 13, and 14, those are called bases. And 7 is right in the middle, and we call that neutral. Now, for cabbage juice, whenever you have red and pink, that pH is around a 2. And so this is going to be a 2. Oh, my little baby Ellie, she says she doesn't want to miss out on the fun. All right, so this right here has a pH of 2. So we're going to actually make a pH table by the different colors. So this we're going to put here. All right, and later on I'll let you guys see that. All right, let's see if we can find something else to test. All right, I also have, oh, you want some goggles? Put your goggles on. Safety first. We're gonna get the real stuff in there. So they're a little big, but I'll wear them. All right. He said no. That's fine. All right, so you want to take it off? That's fine. Mommy will put the goggles on. You want to go hang out with Dada? Here. There you go. All right, so now let's take out some baking soda. Now, baking soda, we like to use it to clean, maybe even sometimes it's in our toothpaste. So we have to ask a question. Is baking soda an acid or a base? So what we're gonna do is we're gonna put a little bit of baking soda into a cup. And I have some more spoons here. All right, and we're gonna pour some cabbage juice. So we always make a hypothesis. Do you think it's an acid or do you think it's a base? Let's find out. Let's mix it up. All right, that looks almost like a teal color, kind of green. So we know by the pH indicator table, which I have actually right here, we know here that this is a base because it's turning a green teal color. So let's put it on this side. All right, so we have blue, we have green. Let's see what else we have here. Now, lately, because of COVID-19, and just in general, we should always wash our hands. But it seems like lately we've been talking a whole lot about soap. And so I figured, hey, let's use some dish soap. All right, and so we have some dish soap here. We find out if it's an acid or a base. Now, kids, when you're washing your hands, do you know how long you should wash your hands with the soap? You should wash for at least 20 seconds. My son, I have him sing happy birthday, and that's usually about 20 seconds. That's usually about 20 seconds. All right, so let me get my cups. All right, let's put some soap in there like that. And we're going to add our pH. All right, based on what color it turns, we know if it's an acid or a base. Oh, wow, that's pretty. All right, so this soap right here, I would say it's slightly basic, a little closer to the pH of 7. All right. What else do I have? Ooh, all right, I have some club soda. So this is like Sprite or 7-Up. So let's see what club soda's pH is. Do you guys like to drink club soda? I think it has a funny taste. All right, so acid or a base? Let's find out. Wow, that's a pretty purple color. So it's not the same color as my water, and it looks more on the red spectrum, so we know this right here is an acid. That's a nice purple color. So we're gonna put that there. All right, next, I have vinegar. Now, did you guys know that science is everywhere? No matter where you look, you can always find science. Oh, I need my cup. Let's get my cups. All right, science is everywhere. When you cook at home, that's science. When you're washing your hands, that's also science. So did you know you don't have to wait till you grow up to be a scientist? You could be a scientist now. Doesn't matter how old you are. All right, so we have vinegar. Let's pour our indicator in here. Wow, that looks very close to our lemon juice, doesn't it? That means the pH of vinegar and lemon juice are very close. Wow, look at that. So we have pink, we have purple, we have a teal green color over here for our base. Let's see, what else do I have? Seems like my household has a lot of acids in it. Now I have a lime. Now, could you guess possibly what color do you think that's gonna, oh, my lime doesn't want to open up. Let's see if we can peel it. I brought a butter knife for safety purposes, but seems like it doesn't want to penetrate my lime. Oh, there we go. So let's squeeze some lime juice. Now, could you guys guess, what do you think the color for the lime juice is going to be? I think it might be acidic. Does that sound right? It's like maybe an acid, so maybe it's going to be pink too. When you form a conclusion based on knowledge that you already know, that's critical thinking. They will say critical thinking. Yes, making a decision based on things that you know to be true. All right, so let's pour some cabbage juice in there. Wow! If you guessed pink, you were right. So that's going to be over here with all my other acids. Very good. So now, this experiment you guys can do at home. All you need is cabbage, and you just boil it to make a solution. And we talked about solutions early, and we could talk about them again. And any household products. Some other products I like to test are liquid ammonia, but you have to be careful. Cream of tartar is another one that you can test, but pretty much anything around your house. You can even take some tomatoes or things out of your garden and test to see if they're acidic or basic. Now, why is it important to know if things are acidic or basic? Well, have you ever gone to the dentist and they'll say, oh, you have to brush your teeth? Well, it's important to brush your teeth all the time, but maybe if you eat something acidic, you may want to brush your teeth right away. And remember we talked about how toothpaste has baking soda in there? Well, when an acid and a base come together, they can become neutral, like water. And that'll cause the acid to not break down your teeth and clean your teeth nicely. Also, the water that you rinse your mouth with at the end also helps to rinse out your mouth so that you don't have too much acid or base in your mouth, and your teeth are nice and strong. Also, knowing things whether they're acidic or basic is important when you're cooking. Have you ever watched TV, maybe a cooking show, and they always talked about, oh, we got to add a little bit of this for the acidity? They always seem like to be talking about acids for those who watch cooking shows. Well, to know if something that you're cooking with is acidic or basic, you'll be able to balance that out in your food and make it taste even more and more yummy. Also, it's just good to know information because knowledge is great and it's fun. So I hope you guys enjoyed today's live event dealing with acids and bases. And I hope next week you guys join in the fun. I'm kind of looking at some of the comments to see if, yep, Rick, my son, he is a great help. It seemed like he got most of the comments. And I hope you guys enjoy it. And also, if your kids have any comments, next week, I hope to be able to do a Zoom, not next week, sorry, in 2 weeks. That's June 6th, I believe, let me look at my calendar, June 6th. Next week, next event, we'll be talking about matter and different types of matter. And so that week, I hope to have a Zoom event. And so it'll be interactive and you guys can join in on all the June 7th? All right. June 7th, June 7th, Sunday at 3. 3 o'clock, we'll have another live event where we talk about matter. And if you check out the page this week, you'll see all the materials that you need so you can join in on the fun as well. Also, all these videos will actually be posted up as well as other videos on my YouTube channel, Joy for STEM. And then you are able to do these experiments at home with your kids. And once again, no matter what their age is, whether you're teaching them about colors, whether you're teaching them about acids and bases, or chemical reactions, they can definitely enjoy and learn from it. And just remember, STEM is super important. It helps to keep the world moving. And so I hope you guys enjoyed it, and I hope you guys join me again next week. All right, enjoy your afternoon. Bye.